Hello, I thought I'd just make a little update video because I managed to figure out both of the problems that I was having in my last video, and also show you the Arduino code that I'm using to run this setup because it's pretty simple and it was related to the problems that I was having, one of the problems I was having anyway. So the two problems that I was having was that it wasn't going from forwards into reverse and vice versa very well. And the other problem was that it would basically just stop working every now and then. The problem that it wasn't going forwards into reverse and so on was due to the speed controller in there. I tried it a bit more and I figured out that it was only going from forwards into reverse that was the problem. You could go from reverse to forwards anytime really quickly, but you just couldn't go from forwards to reverse anytime very quickly. And I discovered that it's not a problem, it's actually a feature of the speed controller. It's a brake, so that if you're driving fast and you want to slow down, you just flip into reverse and it doesn't engage the motor and spin the wheels backwards. It just tries to stop the wheels from spinning like a brake. That's what it's supposed to do. I just didn't realize that because the last time I've been using these radio controlled cars was close to 20 years ago. It's more than 20 years ago, I think. So yeah, the technology is a lot more advanced than I was expecting. So there was actually no problem with the speed controller. The other problem was actually my problem, and it was that basically every now and then the whole radio transmission system would just stop. And I noticed after a bit more experimentation that it was usually after a bump or bumpy surface, driving on a bumpy surface or hitting a object or something. And I was quite puzzled by the fact that when I went over to the car to try and start it again, I noticed that the Arduino still had power. The LEDs in the Arduino were still on. And that sort of puzzled me because usually in the past, if it's a problem that the Arduino momentarily lost power and then reset itself and started again, usually that just means that the program would start running again and everything would be okay. It would just recover as soon as it got the power back on. But in this case, it had the power, but it wasn't recovering, and it would stay like that until I pushed the little reset button, and then everything would start up again. So the batteries were not the problem, the Arduino was not the problem, so that just left the radio RF24 module being the problem. And I used my powers of deduction and realized that it was basically just the little connections here are quite open. I mean, they're just sticking out. And previously I'd had it so that they're facing down, as you'll see in this photo here from my last video. So that basically when the car went over a bump, some of those terminals there would touch on the screw just below it. And so the radio would get reset, but the Arduino would not. So to see why that was a problem, we'll just have a look here at the source code to see how each side of this connection works. Okay, we have here the two Arduino sketches that I'm using. On the left is the one that sends from the transmitter, and on the right we have the one that's in the car. And I've spaced them out so that you can see that they are very, very similar. So we just include the necessary stuff at the top, and then we define the pipe ID, I guess you could call this, and that's the same on both sides. And then we have a structure that I'm using to put the data in, and this is useful if you want to send various formats of data, like it could be an array of bytes, or you could have two floating point numbers, or just whatever. So you would just fill out this structure with whatever kind of data that you want to send, keeping in mind that of course it should not exceed 32 bytes in size. and a byte obviously is 1 byte in size, and in the Arduino IDs, for example, say you wanted to put an integer, that would be 2 bytes, I believe, and you could just put, you know, what values in here, like whatever you need for your application. And you can check the size of the structure just to be sure, to double check. You can do this. Oops, sorry, I'm wrong keyboard layout. You could maybe print this out. This will give you the size that the program detects that structure is, and then you can check that that is within 32 bytes. You could print this out in the serial output or something just to check. Anyway, so I have in here just 4 bytes, one for each axis of my controller. I have a 4-channel controller, but I'm actually only using 2 channels here because I only have throttle and steering for the car. So I'm just using a couple of these. And over on the receiving side we have exactly the same thing. This has to be exactly the same thing because it's going to be interpreting that data that it receives as exactly what this side is sending. So this part, you could almost put this in another file and include it. Might actually be a safer way to do it. Then we decide what pins we're going to be using for the radio, and we have the same thing over here. On the receiving side we have a little bit more. We have included the servo library at the top, and we also have 2 servo outputs, one for steering, one for throttle. The setup procedure starts off the same. We begin the radio, we set auto acknowledgements to false because we just want to spew out a continuous stream of packets as fast as we can. And to help improve the range, we set the data rate to be 250 kilobits per second, a little bit slower than the default, which is 1 megabit per second. And on the receiving side we have exactly the same again. On the sending side then we do open writing pipe. On the receiving side we do open reading pipe and start listening. Then on the sending side we do just to set the default data that we're going to be sending. I have it so that values are between 0 and 100. So a value of 50 means that the joystick on the controller is exactly in the neutral position. So this is what I want to send, just as a first default send, and I do radio write to send that data just one time at the beginning. And then there's a delay here, which I'm not quite sure why I put that in there, but doesn't really matter. I think there are some things that you should wait a little bit for to initialize. Maybe some of the LCD programs, or maybe it was the servo library or something needs a little bit of time. I can't remember. So this data variable that we have here is declared up the top, and that's a global variable that we can access anywhere through the program. And on the receiving side we decide which pins we're going to be using for our servo. So I'm using 3 and 5, and then likewise at this end we set up our current status of our throttle and steering and everything to be in the neutral position, and we have the delay here as well. So you can see they're very similar. There's just a little bit more on the receiving side because we have the servos to manage as well. Okay, and then if we jump down here we have the loop function, and this just runs continuously after the Arduino has been booted up. And on the sending side we do an analog read, and I have the potentiometers inside the transmitter connected to analog pins 0 through to 3. So I'm just taking each one of those analog pins, which will give me a value between 0 and 1023. And if you recall, our data that we're sending here is a byte. and a byte can only store a value between 0 and 255, so we can't send the 1023 range value directly. So what I'm doing here is using map to convert that range of value into a value between 0 and 100. It could also be a value between 0 and 255 if you wanted to keep a little bit more of the accuracy. I just find this a little bit easier to interpret when I'm looking at the values. I was looking at the values on the OLED screen before. I don't do that anymore, but it's just a little bit easier for me to think about what does that value mean when I see it. And you can see I've had to reverse some of these, just a bit of trial and error to see which ones need to be reversed. So this one goes from 100 to 0. Not actually using all of these, but just writing them, reading and sending them anyway. So they all get set into that data structure, and then we send it. So this is pretty simple. In fact, for this application with the car, we could just do that. That would be enough to handle the throttle and the roll would be steering. So that's all that happens in the loop, over and over and over. Not much really. Alright, now on the receiving side, we have to do a little bit more because we've got the servos and stuff. So we have a value here that just keeps track of the last time that we received a packet from the transmitter. And inside the loop function, we check to see if we have any data available from the transmitter on the radio, and if we do, we read it into the data structure that we have over here, and then we set this last received time to be this function here returns the current time in milliseconds. So we just keep track of when we received the last packet. And this is a while loop, so this will just read all available data as quickly as we can, just to get it out of the buffer that the RF24 module has. I think in most cases this will not actually loop, it will probably just run once through each time, so it probably doesn't need to be a while loop, it could just be an if. Okay, next thing we do is we use the milliseconds function again to check what current time is right now, and then we check if the difference between now and the last time we had a packet is more than 1 second. So this is 1000 milliseconds, and if more than 1 second has passed since we received the last packet from the transmitter, we set the throttle and the steering to be values of 50, so that's neutral, so the car is going to stop moving and the steering will return to the center. Then we do another mapping, so we take our values that we have for the throttle and steering between 0 and 100, and we convert those to values between 40 and 140. This is because the center position for a servo will be 90 degrees, because servos range from 0 to 180 degrees. So 90 is in the middle, and I found out just through a bit of trying and looking at these numbers and testing them, trial and error basically, that when I moved the throttle past 50 degrees away from the center, so that would be T is throttle, I think, yeah. I found that the throttle didn't increase anymore after that. So it seemed to me that basically starting from having 90 degrees in the center position, 50 degrees each side is the full range of movement that servo is expecting. I'm not sure if that's correct, but it seems to work pretty well. And it also seemed to be the case for the steering servo as well. So that's why I'm using 40 and 140 here, and I have them reversed here because if you recall I had the steering backwards originally. So I just reversed this mapping here. And then we just write that to each of the servos. The throttle servo is not actually a servo, of course, it's the electronic speed controller, but the electronic speed controller pretends to be a servo so everything works quite nicely, and it's pretty easy. Alright, so what was the problem? What is the problem here that stops things from working when the radio resets? Well, it's pretty simple, really. The Arduino never got reset when the radio got reset. So the Arduino is in this loop all the time. So the problem is that the radio is never set up inside this loop. If we look back in the setup function, this is the important thing that the radio needs to have done after it bumped into the screw and got shorted out, and that was never happening. So basically, after it touched the screw and got shorted out, the Arduino was just running around and round and round in this loop, and this radio available would never be true because the radio was doing nothing because it had never been begun again. So I'm pretty sure that's what the case was, because once I made sure that the radio module was a little bit more secure and it wasn't bouncing around and it couldn't touch any metallic things and get shorted out, I never once had a problem after that. So I've concluded that that was indeed the problem. I don't really think you could do anything about it in the software part here. Perhaps there is a way that you could detect that the radio wasn't doing anything, or maybe you could just call radio begin again every now and then. I don't know if that would work, but in any case, you don't want the radio terminals to be touching on things and getting shorted out in the first place, so you might as well just heat shrink them, or wrap them up, tie them down so they don't touch on anything. Now, on the helicopter side of things, I've also been making some progress. I've got most of the electronics ready to go, but I still don't have any batteries. Unfortunately, even though I ordered the batteries at the same time as all this other stuff here, the batteries just seem to take forever to arrive. They can't be shipped by airmail, I think. That's the problem. So I haven't been pressing ahead with this too much, but it's almost there. So just have a look at what we have here. We have the cheapest possible airframe. This is a 25 centimeter nylon, a little bit on the heavy side I think, but not very big. It's this one here, quite cheap. And on there we have, I think, almost the cheapest flight controller board, and that is a OpenPilot Copter Control 3D, otherwise known as the CC3D board. And we have a set of motors, which are the RCX ones. It's a little 2400 kilovolt ones, and what I think is also the cheapest possible speed controllers, set of those. And on the bottom here we have I think this may also be the cheapest possible, you can't actually see it under there, but it's this power distribution board, and that I like that one because it's kind of small, and it also has two step down voltage converter things on it, which you can use to power your Arduino or your flight controller and stuff. So I've drilled a few holes in there and I'm bringing the power through. Oh jeez. And I'm bringing the power through to the top under here. It's a little bit hard to see because I've been fluffing around and making it look all nice and pretty and compact. And I even made this fancy plastic cover for it, so it'll look all nice when it's done, and it's going to be perfectly flat, so you could actually put a battery on top here quite easily as well if you wanted to. So as far as getting everything running with the Arduino, this is all we need here. On here we have the red and black are ground and 5-volt power, and it seems to work with a 5-volt Arduino, but I will be using a 3V Arduino when I get that. That's still in the mail as well. And the white line on here is a PPM signal line. So there's 4 channels coming from the transmitter. So you could do that with 4 wires of PWM signal, but you can also do it with just 1 wire of PPM, which is much preferable, I think. Makes things a lot simpler, lighter, easier to put cables around the place and stuff. So that's what I've chosen to do. And just to show you how it all works, I will plug this into here, and need a battery. I'm just using the battery from the car. I can't really fly with this one, I don't think. It's too heavy. And just plug that in. And turn the transmitter on. You can see nothing happens right now because it's not armed, but you can set up how you want to arm it on the CC3D program. It's quite cool. So we arm it by going bottom right on this stick. Now it should be ready to go. And I don't think you'll really be able to see very well in the video, but maybe you can try this. I forgot to do this before. That one goes that way. That one will go this way. Stuck on there, are we? Okay, never mind. You'll just have to believe me. The motors are all spinning, and they're all spinning the right way, and the levels are a bit different. And they react when I tip the frame around. And yeah, this is not a very good demonstration, but you can see that, for example, this motor over here, when I tip it upwards, it actually stops because this is the one that needs to go fast to correct the tilt. And when I tip it that way, see if we can make them a bit slower. There we go. So this one actually stopped. Okay, they all stopped. This demonstration sucks. Well, just trust me. Everything's working as it should. And the only thing we need to do now is get a lighter battery and make another version of these two things here, just the Arduino and the radio. We don't need to have a screen or anything. And as it turns out, there's quite a nice little place right on here for an Arduino to go. It's almost like it's screaming, Arduino goes here, like that. Look at that, it's a perfect little spot. It sort of sits in there just snugly. So I think I'll put that there for now, and that will also leave those pins sticking out like that to be a little bit easier to connect. And speaking of easier to connect, the USB for setting up everything goes in there like that, and that can be accessed with the sexy cover on top as well. It all sits flush, very neat looking, I think. So that's what happens when you have a long time to mess around with things when you're waiting for batteries. So anyway, hopefully in the next video we can see something flying, maybe. Right, anyway, thank you for watching. Oh yes, and one more thing that I got or started on. I know I kind of joked about getting rid of this crappy transmitter unit a while ago and buying a proper one, so I kind of did. I got this one here on Yahoo Auctions second hand. It was last used 10 years ago and is not in such great shape, so I got it for $15, which is pretty good. It's a decent controller. But the main reason I wanted to do that was because this is really quite crappy. I was driving the car the other day and this stick thing just fell right off, and I've lost the front for it. I think I might have thrown it in the trash actually. And it's just generally not a very confidence inspiring thing to be using. I think I'll keep it for using with the car because that's not such a problem for safety, but I think I owe it to anyone who happens to be standing in the general vicinity when I'm flying a helicopter to have something that's a little bit more reliable. And this also has some very nice features in that it has some nice meaty switches here to use, and it actually has another analog dial there. So there's 5 switches and analog dial and the usual controls. Much nicer feeling stick movements as well. This is a 5-volt system, unfortunately, so I can't use it directly with the 3-volt Arduino. So I think what I'll do is use a 5-volt Arduino in here and get a little step-down thingy so I can power the RF24 module from there. And I haven't really started cutting any wires inside here yet. I may cut some things out, but for the time being it has some useful features. One is that although none of the controls or anything work anymore, seems to be broken in that respect, it does show you the voltage. It's 10.4 volts there, and it also beeps when the voltage gets low, just to let you know that you should probably replace the batteries before you keep flying. So I thought that was kind of handy. Another handy feature is that you can charge the battery pack from here directly, and the battery pack of course was useless because, like I said, it was 10 years old and it was just garbage. So I bought some rechargeable nickel metal hydride batteries, some new ones, and made the sexiest battery pack you have ever seen and put that in here, so that should work pretty well. And there's plenty of space inside there to put an Arduino and a nice little spot for the antenna to go. So that's what we're going to be using with the helicopter. Okay, now I'm done. Bye.